Welcome back, everyone. We start with our first keynote speaker, and I'm really glad to introduce Jörg Tiedemann. Jörg is, you all know Jörg, I think. I think everyone used Opus, so Jörg is the Opus guy. He's professor in language technology at the Department of Digital Humanities at the University of Helsinki right now. He received his PhD in computational linguistics for work on bytext alignment, which then led to Opus, of course, and machine translation from Uppsala in Sweden. And then he moved to Groningen for doing a postdoc, and there's where I first met Jörg. It was in Groningen, I think, or at least at the CLIN conference, which is computational linguistics in the Netherlands. So his main research interests are connected with massively multilingual data sets and data-driven natural language processing techniques. He's also running an ERC project, which is very nice to have one, on representation learning and natural language understanding. And he will talk today about democratizing machine translation with OPUS-MT. So Jörg, the floor is yours.
Very much. Back with the audio. Is that working? Yes, thanks a lot for the invitation. It's really great to be here at a real conference, seeing real people. I don't really know how to behave. It's a long time for me as well. Now I'm also here, one of the keynote speakers is even better. But even more uncommon for me as well. So nice to see you here all. And I will talk mainly about Opus and OPUS-MT, as you would imagine. So if you expect something really novel and innovative, you will be very disappointed. It will be a lot about practical things, making things available, opening tools and resources to everyone. So this will be the main focus of that talk, which is kind of the mission of OPUS-MT and Opus itself as well. I have a little bit of motivation, which I probably can skip mostly, because this is something that I don't have to convince you about. As we are working with language technology and machine translation, we know that this is very important also in practical applications. Digital channels, everyone is using them all the time, and language technology is really driving those digital channels. Language technology is deciding what kind of news we see, what kind of things we get recommended. So all the kind of behind the scenes is so much driven by technology, which gives, of course, also a lot of responsibility to our field. And as we also all know is that, of course, language technology nowadays is really driven by resources, data, basically. And as data is not always available, it becomes more and more available, but only for a few languages. That makes, of course, a big problem to the society, as this is driven by language technology to a large extent in those digital means. If we have this inequality popping up by just having a very skewed distribution of language resources over all those different languages, this becomes a real problem. Well, I don't go into details of that plot here. It's just showing that Wikipedia pages could be a proxy for just showing how much resources are available for certain languages, and we can see that's always the problem of the long tail. Not only inequalities rise from that, discrimination based on language use, there's also another thing that is actually worrying, is that because people are used to having digital tools around and using all kinds of practical applications, this also leads to some kind of way of languages disappearing. So if languages are not supported by the means that people in society would like to interact with, then this leads to some really distinct extinction of languages. So there's this term digital language death that has been coined. If languages have not that support that people would really require, then this endangers the languages themselves. So this is also something where, again, language technology has a real big responsibility. So all that leading, of course, to the initiatives that we need to increase the coverage and getting away from those kind of language barriers. And again, I think I'm talking to the wrong audience. We are all on the same side here anyway. So we know that we are working on tearing down those language barriers, and we know that we have to support under-resourced languages. But still, I think we should always repeat that kind of mission again and again, because we are too easily going to the common benchmarks, working on English again and working just on the same languages and just forgetting about the long tail. And this is something that, of course, we would like to focus on more. There's various other aspects as well. So if you also see that people really use language technology for getting information, access to information is really a human right, I would say. And it's not only across languages, but also across modalities. There's also the need of language technology to make that broken link available for people who have certain handicaps or disabilities. So again, something that we really need to address. And then very current situation also, we have seen a lot of emergency situations that require to be, to require that people need to get information quickly in all kinds of different languages as fast as possible, and that really saves lives. All the initiatives for making things available for other languages include that we need to have technology around that quickly has some response to emergency situations like we had with the COVID situation, and now Ukraine as also at one of the big crises ongoing. So how do we deal with refugees coming from different countries, trying to integrate, trying to find their way around. And a lot of things are happening, and I'm really glad to see that. And I would like to talk a little bit about that as well, for example, in the initiative of building Ukrainian language technology solutions. So there's a lot of things going on, and again, I don't really have to motivate that too much. One thing that I would really like to point out is that, especially from the academic side, we have this responsibility of being transparent. Because I hear that quite often that now when you're working on machine translation, the typical idea is that why would we still give funding for research projects on translation or language technology if you see that big companies are doing it much better on a larger scale, having all the resources and so on. On the other hand, I would say that this, because we have a human right to get information and access to information, this is a very risky strategy, is saying we outsource everything to just commercial products and commercial ideas. Because in that sense, we really lose that kind of transparency. It becomes behind some kind of commercial exploitation, which gives less control over what we are doing, and we cannot really say that who is really controlling the big models and the applications that are developed. Can we really give the data out to the companies that of course have to increase their profit? So there's a profit orientation which makes that a bit of a tricky issue. Also, what kind of languages needs to be supported? Should that really be driven by commercial interests, or is it more like this general kind of human right that we should support? So all of that, of course, is a bit of a motivation for things like OPUS, OPUS-MT, and things that I would like to talk about. So going to the essence, OPUS-MT is kind of a continuation of collecting data, but then also making models more widely available, not only distributing data sets and making things easier to replicate, but also really as now pre-trained models are very important and people are using them, we should also do that for all kinds of models that we are training, giving them out and making a good starting point for many of the research projects that are running. So what we try to do is to exactly do that kind of thing, trying to have that mission that increasing the coverage of languages, increasing the availability of models beyond what is currently done already in other places. And it's not, of course we are not alone in that, but I think we play some role in Helsinki with this initiative quite a lot, as there's a strong focus on getting tools and models out. I have two links here, so I don't know if you know OPUS-MT, but there's basically everything is in development, online available through some websites. Maybe I should, well, I don't even know if this first link is the best one to go to OPUS-MT. Most of the things are published via GitHub, so there will be GitHub repositories having all kinds of information and further links to resources that we develop. I can talk more about this Tatueba challenge also later. This is especially to make it completely easy to get started with machine translation research, and we have some little visualization of a map where we can also monitor the coverage of those models. So that was kind of the introduction, but I'm still a bit in the background section here. maybe most of you know Opus, but I'm still going a bit into the kind of history of how this developed and you know, what is Opus exactly. Maybe some of you don't really know exactly what Opus is and how that leads to OPUS-MT and what is included in OPUS-MT. So Opus is something that started basically as a kind of coffee discussion after a summer school in Norway. When I was a PhD student, we were sitting together and I was thinking of that it's really a shame that there's no parallel corpora available. This was, I think, in 2004, so quite ancient time nowadays. There was basically nothing available. It was all before Bleu even existed, I think. So Opus developed very slowly in that time. It started by just saying, okay, there's localization data online available. Why shouldn't we not just collect that and carefully prepare that to make it available for, at those time, extracting, for example, bilingual lexicons and getting word alignment done on a larger scale and having this really available for everyone. I think it was kind of unnoticed for quite some time because it was very slow and probably small. And didn't really have that big impact on other kind of research. But slowly, I think the increase of popularity just came because there was also many contributions of other corpora coming out, and we tried to integrate most of those things into one collection to make it very consistent and easy to get started with just data. So it's very boring work that someone has to do, but it's kind of very important to have that done, so you get same kind of format for lots of different data sets. You can download them and use them directly for anything you would like to do. So you can search for language pairs that you are interested in, and you can see what kind of resources are available. And this is basically the essence of the collection. So nowadays, it's a bit tricky to impress people with size, but I think even nowadays, Opus is still a very big collection of parallel data, at least. So parallel data is still an expensive thing to get, and especially with the coverage that we're trying to produce here, this, I would still say, is quite an impressive collection of data. So nowadays, if I say 12 terabytes, I think most people start to laugh because that is kind of not even saying anything about petabytes or whatever is now a common unit. But if you think of release data, textual data, compiled into parallel corpora aligned across different languages, this is a very impressive size still. Language coverage is a bit tricky to say as well because you first have to define what is a language variant, and so on. But there's several hundreds of languages at least. So I counted something like 626 languages without the regional variants, and that's according to the ISO standards that are given in the data sets. And the main important point is that I would like to produce everything so that this is ready to be used. So really aligned and parallel, so you can really just pipe it into your system if you're interested in machine translation, for example, or other kind of cross-lingual research. Making this as complete as possible, saying that all kinds of parallel documents should be aligned with each other. It's not just an English-centric thing, but any kind of language pair should be aligned. That's one of the philosophies behind building up Opus. So if you combine this, of course, this is quite an extensive combinatorial thing. So over 40,000 language pairs are now inside of the collection, prepared in the same way, so you can really get them for whatever you like. Of course, the distribution is very skewed, so not all of those languages have a lot of support, but you have at least a starting point, and you have quite realistically scenarios for something that is high resource or lesser resourced scenarios, for example. I think the next numbers are probably even less impressive nowadays. If you say 20 billion sentences, doesn't really sound a lot, but this is across all languages, but then they are aligned in various ways also, so they appear in different kinds of byte texts. And you have billions of tokens, of course, in all of those sentences. I think many people know that there's some kind of XML format in the behind the storage. All kinds of other storage formats are actually produced from that native format, but which allows this kind of extensive alignment between the different pairs without really multiplying the same data again and again if you have different language pairs covered. So you have a standoff alignment between the XML files, but it's very kind of simplistic XML, so nothing really blowing up to something very complicated. Okay, don't want to spend too much time on that, but also some practical things that maybe some people don't know. I think most people probably just download something from the website, but there's also an API to find resources, which makes it very practically accessible. So you have this API where you can find the resource that you need, and you get listed all the resources that you can download from the repository. And to make it even more easy to really work with that, we have developed a Python package that gives you also the tools where you can find and download, fetch the things, and convert between different formats. So you get it basically ready down on your local file system with those tools. It's very easy to use, and extracting the data as you like. So I recommend having a look at that. So bit more history. So once we have a nice framework and setup of Opus, then of course the next step would be to do something also more systematically. And we started, well, of course we always used the data, and many people use the data, but now we started also in Finland to have a very small scale project in the beginning to support the two national languages of Finland, Finnish and Swedish, and saying that, well, because those are two national languages, should be supported with open translation tools and services. So we set up this OPUS-MT project, which was the focus on developing exactly those kind of tools and services for Finland, and to make them really accessible to anyone in research, development, and also end users. So I think this was a project that gave 70,000 euros of funding, very small scale, if you compare to whatever other things are set up. But this was the starting point of, I think, quite a big development that made, at least from my point of view, quite some impact. So once starting with Finnish and Swedish and setting up pipelines and doing all the procedures, the natural thing is, of course, to say, okay, I do a for loop over everything in Opus. So this is the beginning of OPUS-MT. We can reuse the ideas that we have already developed in this kind of pilot project, and now think that, well, why not just do it on a larger scale and doing it more systematically. So OPUS-MT I will start talking about a bit more in detail later. But then also for us important was that this not only goes to our internal research or maybe some other research in machine translation, but we were always interested in having a good integration also for end users, for professional translators and so on. So one of the already starting at the OPUS-MT project, we made integrations into computer assistant translation tools, so plugins that make it straightforward for people to just use any of the models that we are producing. So integration is basically integrated in a nice interface, and even professional translators can access everything we do. Okay, just quickly to say what we do with ourselves with that. Of course, we have a lot of projects where OPUS-MT comes into our projects. So now we have a nice framework, we have pre-trained models. We can inject that to many of our own kind of projects, which is nice and makes it also much more easy to progress. We don't have to start from scratch and deal with all kinds of low-level questions first. So don't worry about the projects. Maybe the most important thing is that we also have external collaborations with the Wikimedia Foundation. We should actually reactivate a bit more, where the idea is that especially this kind of accessibility is an issue, that you can get Wikipedia pages more quickly translated or produced for other languages. They are interested in having machine translation as a tool for accelerating that. And then I think also a good step forward is, and maybe many of you know already that as well, the integration in those popular frameworks, not only having it from our Helsinki GitHub that no one finds otherwise, but if there's kind of Hugging Face, then everyone is happy. So integration in Hugging Face, I think, was a good step forward to make those things really spreading a lot. So it's a bit of a responsibility now on our side also to get that kind of up to date all the time. So it's not perfect, but there's a lot of models already integrated in the Transformers library and in the model hub at Hugging Face. And I see that some of those models are really popular and they're used a lot. I'm almost shocked that this is kind of taking off quite easily, especially for some language pairs. And we also had funding from the European Language Grid on this OPUS-MT project, where we made an integration into the infrastructure of the ELG. Also this again then makes it easier to really use and exploit the systems. Okay, so OPUS-MT. So a bit more details about that kind of setup. How do we do? So OPUS-MT has two different parts basically. We want to publish also the training pipeline, so make it really transparent and easy to replicate. So basically is my own kind of fiddling around with training pipelines, but we try to make them available and that you can use them yourself. And all kinds of things and tasks, common tasks that you have to do. As I said, nothing really novel and new, but the common things that you need to do to get a decent model will be integrated in those pipelines. So you can fetch and prepare the data for any kind of language pair you're interested in. You can train your NMT model. The backend will be Marianne NMT based, but as we now have conversions to PyTorch and Transformer, so this also makes it then easy to integrate in other frameworks. There should be also support for multilingual NMT. All this kind of fine-tuning and back translation, pivoting, evaluation things are integrated. So that makes at least my life much easier. Maybe others also could have some benefits from that. And the second part is then more about integration. So how to use those models into in the purpose of setting up, for example, machine translation servers. To use them, integrate them into your workflow. There's some kind of probably a bit still more experimental, all that kind of implementation of setting up a server where you can then run the systems and translate really things with the models that we have pre-trained. And of course, we publish the models, and I should update those numbers more carefully also. So there's certainly more than 1,000 models that I've thrown out. So my policy is typically I just publish as much as I can. And then I hope that at some point someone gives feedback and says, this is rubbish, take that away. It happens not that much actually, which can have different kinds of reasons. But to have all that kind of available collection of models makes it easy to just pick whatever you find decent and accessible for yourself. So just an impression how that looks like. So this is probably not too much interesting, but just to give you an impression how easy that would be. Dockerized solutions for OPUS-MT basically means that you can install it yourself from GitHub, fire up the Docker or compose the Docker image and then run it, and you get your server with a nice and very simple interface. So it's nothing for commercial purposes here, but you can just have it on your local machine in that kind of way. And maybe others who don't know about that also know with the integration into transformers, you basically have to write 3 lines of code, and that already gives you the translation engine that you need. So all this stuff will be done automatically by the library, downloading the model from Model Hub at Hugging Face, and you can start translating immediately after you have done that kind of first setup. So there's nothing really more than to do than just pip install the transformers library and then running those 3 lines of code, seeing what kind of model is available, and you get your engine up. There's 2 other ways here from the ELG and from Docker itself, but let's maybe skip that a bit. But just for showing you that this makes it easy to really run your own translation service. So training MT models. Clock actually at some point I have to. Okay, great. So as I said, there's nothing really very exciting. I don't have new models and billions of parameters and so on. But I just want to show that I think this kind of basic work needs to be done because people are doing the same thing over and over again. But if you have things already starting, if they're set up and you can more easily create your baseline, for example, or the essential model, this helps a lot to get started with any kind of research. And the idea is that those pipelines should be widely available as much as possible. So you can again just get the code, get all these submodules installed, try to make that more streamlined all the time, and then you would just select certain parameters of what you want to use for training, and then you can train the system with the basic setup. And you will, if you have your resources available, like a GPU server or several of them, then you can train your system and run the typical things that you need to do, like training, evaluation, and releasing. while releasing, we can talk about that at some other. That needs maybe some permissions to get to the kind of repositories. But the training and evaluation should be possible for anyone to do as in the same way. And a bit more interesting is maybe this capability of doing multilingual NMT, as I'm also very much interested in that, of course, transfer learning across different languages, and having multilingual models to set up. Also, you want to explore that more systematically, what kind of multilingual models would be nice to compare with. And then, so as you have seen already in the previous picture, there's this simple kind of parameter target length and source length, where you can say what kind of language are we interested in, what should be included in the source languages and target language sets. So this is what I'm of course exploring myself quite a lot as well. And then there's certain facilities in the pipelines to give you recipes for doing all kinds of different models. So here, just to give an example, so I try to really make it easy for myself, basically, and maybe someone else could also replicate things with the same kind of recipes. So I was interested in being more generic and systematic about seeing how can, for example, related languages put together into a multilingual model, and I can base it on some kind of standards that define language groups, for example. So in this case, just to make it more convenient, I could, for example, fire up training pipelines for training from Western Germanic languages to Romance languages, and behind the scenes, this will expand to all kinds of data sets, which are available from here, this Tatoeba translation challenge data set that I'm using. It will fetch those things, train it, and make it ready, available for that kind of combination. Of course, there's lots of hyperparameters or kind of different properties that you need to set. So you might want to oversample and undersample the language pairs if they have different distributions, so different sizes of training sets available. And there's, for example, certain parameters that you can set that you do some temperature-based sampling, for example, that balances between the skewedness of your data and the uniformity of available data across language pairs. You can set certain thresholds also, that the size should not be above certain size, like 10 million sentences here, for example, and those kind of things. So very practical kind of tools for me to explore things. And again, this then makes it possible to just do this kind of basic research, which is maybe not done that much, where you can find out how much transfer learning do you get from putting languages together for a certain model class, for a certain model size, and then seeing where's actually the best balance between having many languages included versus having larger models with lots of languages. And if you then have, for example, this possibility of having language groups grouped together and getting most out of related languages, you can see that, okay, having Slavic languages put together into one side, one kind of input or output side, then I get a nice boost in performance, for example, for a lesser resource languages like Belarusian, which is very close to Russian, of course. Just to give an example. But I can kind of explore all those kind of different language groups and language pairs easily. Quickly about Ukrainian. This was then, of course, also for me kind of a very important that language technology becomes visible in the crisis that is ongoing. And I thought that, of course, OPUS-MT needs to also find a way of pushing the performance of machine translation for Ukrainian into languages which are typically the ones where refugees would go to. Or other kind of, well, Finnish was maybe not the best example here, but it's for me interesting. But so the kind of setup is of course easy then to use. We use the kind of framework, but then there's certain other things that we can really do. Again, very simplistic things, like we can have this triangulation, that was the previous part here, very easily using already existing models that we have trained for translating between Russian and Ukrainian, for example, or between English and Finnish, using very strong translation models for those language pairs to create artificial training data for Finnish and Ukrainian. So we can exploit the resources that we have available without doing a lot of retraining and new things. We can use those very strong models to translate one side into the other language and create decent training material that we can use. We can also do some kind of pivoting over English for English-centric data like paracrawl, and maybe people also know that we have in Opus this kind of pivoted version of paracrawl, where multi-paracrawl is trying to fill the gaps between the different languages by pivoting through the English sentences. So we also get decent amounts for Finnish-Ukrainian in that way, and then we can do all those kind of back translation tricks and so on to augment the data and finally improve the performance of Ukrainian translation. So all very down-to-earth, very simple things that really don't excite anyone in bigger conferences anymore, but it's just very easy to forget about those kind of things, how important they are, to get the pieces in place. Another thing that also I think is really important is that it's very difficult to keep track on performance. And we had already a good talk on evaluation. And someone said that if you put people working on machine translation together, they always will start talking about evaluation after 10 minutes. It's probably true. Because this, of course, you need to show that you're succeeding. But it becomes harder and harder, I think. So also the WMT, the kind of matrix disappeared somehow, where you could look up what happened in the last WMT evaluations. Also, if systems have been submitted afterwards, they will be listed there and so on. So we are setting up at least this OPUS-MT leaderboard, also making it for myself easier to see what is the progress for a specific language pair, for a specific test set, and comparing just simple scores like bleu and character F. And I should really talk about the people from Unbabel to get some other kind of metrics involved here. So I would like to set up actually a Comet server for this, having as a service, integrating this in the leaderboard, for example. Okay. Am I doing okay with time? Yeah. Okay. So some ongoing things, scaling up and scaling down is here the topic. So this maybe sounds nice and fine, but is this really useful for you? Is one of the questions. How good are those systems? Is this really state of the art? What is really? How much do we push the limits that we have? So I would say that OPUS-MT is still quite a new thing. We try to capture language coverage as much as possible, but we focused on rather small, compact models like these transformer-based models. So actually this was the appreciated thing so far, so on Hugging Face, because the models are small, you can easily use them, and they have a decent performance. But of course they have a limited performance. They mostly have been trained for 3 days. You can imagine if you have those thousands of models, it's quite a lot of computation that we already wasted with that. Well, not wasted, sorry. We have used that so of course we have to limit our resources, even though resources are quite well available in Finland. But we have also, for the multilingual models especially, the problem that those base models are too small. They don't have the capacity to really perform well. So what we are working on is, of course, going to slightly bigger transformer models, having stronger baselines and better multilingual models. And then general question, maybe, I don't know if you know, but with the leaderboard it's now easier to see also what is the performance that we have for the pre-trained ones that we have available. And it is, well, as it is really difficult to compare now across, nowadays you almost have to look up all kinds of papers to get that. So just comparing to WMT, you can see that also already the models that we have here are not underperforming. So if you look at Finnish English as one of the interesting pairs here for me, we are on par with the best models that have been submitted to WMT, which is a good sign. And if you see that, well, even the base model is very close to the best that had been submitted to this WMT matrix when it was still available. The other direction, also to show that the other direction works as well, so Finnish, English, English, Finnish, you can see that we don't have a big problem. So now you might think, of course, you're a guy from Helsinki, spend a lot of time on Finnish. No, I think it's across the board that we have decent performance for all kinds of languages, even the very high resourced language pairs like English, German. So the performance is really, it's not a play tool. It's something decent that you can use. So in a sense, those models are probably not state of the art, but they have a good performance that everyone should know about. I see a lot of papers where you see scores related to some other kind of baseline. I think those are more the baselines that people should refer to, as those are the things that you can achieve without doing any kind of fancy new things. And I have to also add that those things, those models are never tuned for the specific task. You can really tweak them so much more for just tweaking for the specific task that they could squeeze out much more out of them. Okay. So this was a bit about kind of scaling up a little bit, just getting those slightly larger models. But now, very interesting for me is also to really keep it down, as we have the interest of having things very efficient and available for downstream applications. And then, of course, knowledge distillation comes into the picture. And again, nothing really new and fancy here, just reusing techniques that have been explored otherwise. So just the simple idea of having now our models that we have trained, the teacher models that we can use from our repository, and then training even more efficient student models out of those. And we are reusing techniques that have been proposed in the literature. So for example, the Edinburgh team has then done kind of papers about how to, also implementations in Marianne NMT, where we can easily adjust to the architectures which are recommendable by other researchers. So basically downsizing the decoder is one typical strategy, going to some recurrent networks, reducing the amount of parameters that you use and so on. And now, as we have a nice framework with Opus and OPUS-MT, we can more systematically, again, exploiting what is happening. And just one example, so this is all ongoing work, of course. We would like to explore that more systematically for all kinds of language pairs, but here the typical picture is that if you downsize the model, then of course the performance goes down, like for example the Finnish English here. And if you have those distilled models, then they recover quite well from the performance loss. And as you can see, in all cases, we have this nice performance boost according to some blur measure here, of course, again. But this shows that we can squeeze out in compact models nice performance with just a little bit of drop. And we can see how well we perform compared to some other kinds of baselines. So nice thing from a practical point of view is then if you look at the sizes, so we have seen before that things cannot be deployed anymore. So our models definitely can be deployed by any kind of local machine. As you can see, even the big models are still by 890 megabytes of the model itself. But if you distill this down to this tiny model, you get just 10% of the size, which is a nice, very nice reduction if you look at this little drop that you get. Then you quantize even that, so you get, again, a factor of 4, and you have something that is a 23 megabyte model. So nowadays, if this is, of course, tiny compared to whatever systems are otherwise putting up these billions of parameters. And then looking at speed, this is for me also incredible. If you do that kind of trick of downsizing and quantizing, the translation speed is amazing. You get, for example, on this test set from Tatoeba, which has almost 50,000 words, you can translate that in 10 seconds. So this is, of course, a very nice performance. And if you do even some kind of short listing, then you get that down to 6 seconds. So this is perfect. Okay. So this is all available also in some kind of experimental interface where you can see translate as you type. You can do that. This is also, again, from the Edinburgh team, the translate locally interface. You can see how some of those quantized and student models are working. So as I should speed up a little bit, I might skip the Opus cut thing, and you can ask me about that later. So this is the integration into cut workflows, because I would to also talk about another topic that I had on my mind. So you can keep that in mind. Opus cut is something that I can talk about if you want, for the more translation professionals. Sorry for that. But I also wanted to bring up things that we are really pushing forward now, is going to modular multilingual NMT. And of course, we are also not the only ones. Again, this is nothing really novel, innovative, in a sense that no one is working on modularity, but this is again motivated by the increasing size here. No one can deploy those models anymore if you have huge multilingual models with a capacity that is just increasing all the time. And many people have recognized that we need to go to something that we can manage. So going back to some kind of modular architecture, I think is one of the ways to go. And we have been working for some time already on that idea, making things somehow connected to some shared parameters between all the different languages, and then having more language-specific modules that take care of decoding and encoding. We had, so this model is called the attention bridge, as this is kind of making a bridge between encoders and decoders, and in that sense it's a bit the opposite direction as the adapter hub or adapter ideas that people have nowadays. As you have on top of some big gigantic model in the middle, you would have some adapters on top. We have a kind of lightweight intermediate thing, and then having a full-scale encoder decoder. And I think we can go in both directions to balance between the size of this intermediate thing and the language-specific parts. So, but the idea is here that we would train the whole thing as one complete architecture where all those things are interconnected between each other with this bottleneck in the middle, which is this attention bridge. And then once this is trained, you have nice modules that you can just plug and play with and put together as you need. And you have a very small and lean architecture where you take your encoder that you need for the language you need, take that kind of intermediate representation that you need also to bridge between that and other languages, and take the decoder side, and then you have a very kind of small scale module that you can use at inference. So we're working on that. So a bit of kind of proof of concept things. So one thing is to show that this is really working. This is for image caption translation, just to show that that we get a boost by having multilingual models. This kind of red bar here shows that having more languages really pushes the performance above what bilingual models are doing. But then the zero shot is of course also interesting. So if we have now no data for Czech, French, how far do we get compared to the bilingual model that has the data included? So just for proof that this is happening, that you can have this intermediate representation that is bridging on a very abstract level, this seems to be happening. Also again, not new, as many people have shown it. So then for our project, also mainly interesting is of course that what can we do otherwise, not only machine translation, but this kind of encoder itself maybe could be interesting as well, to map to some kind of very abstract meaning representation in the middle. And we can use that for other kinds of downstream tasks that need inference over that semantic representation that we get. Running through all of that very quickly, sorry for that, but just also here a bit of proof of concept for that. So if this is happening with our initial attention bridge model, we basically can show that multilingual models have a better abstraction level to give better scores on some kind of downstream evaluations and linguistic probing tasks. So those numbers are very low now in compared to the state of the art, but the training was very low in that case as well. And here those things are interesting to just also show that this kind of bottleneck where we force things together in the attention bridge representation seems to promote better abstraction between languages. So you can see that the performance in linguistic probing tasks goes typically up if we increase the number of languages, whereas if we compare that to some basic transformer-based model where everything is shared, the tendency is not visible. So you can see that it basically has no additional kind of abstraction that it seems to pick up. So I need to go to the end. So this is what we are working on right now, is to actually scale it up to make that training possible. So now we have the idea of massively training, but now we still work on things that are basically one network that can be trained as a whole thing. So how can we train a big modular system across all kinds of different nodes. So those challenges are we are actually facing at the moment. How can we set up an optimal distribution of all those different languages and language specific encoders and decoders across a bunch of compute nodes, and make an efficient training procedure that then trains the whole system by communicating between the different systems and updating parameters and so on. And this is much harder than you think. So just to give you the idea that now the problem is that we cannot simply just copy the system to all those different nodes and train them on those different nodes, but we have to decide what different kinds of language setups need to be placed in different nodes, and how to make the communication efficient as possible to avoid any kind of idling and making really the inference, the kind of training procedures as efficient as possible. So we have no perfect implementation for that yet, but we are working on that. If you're interested in that, we can also talk about that more at the poster tomorrow, I think. And I might not need to talk much about that, but then one question is also how to balance the size of that intermediate shared representation and the language specific parts. So how much power do you want to give in that kind of shared part compared to what you want to do language specifically? So that's the promotion for the poster. Please go there and ask for more details. So this is basically my last slide, or second last slide, I think. So just to wrap up, so we have lots of ongoing work related to those practical things. We work on better cleaning of data, for example. There's Opus filter for cleaning up data sets. There's also an upcoming project where we want to increase the data size that we have and integrate into Opus, doing everything bigger and better and faster and whatever. And then we have more integration work also ongoing. So for example, for the Ukrainian language technology, we have made a Telegram bot that you can use for translating. I just this morning, or no, well, the last week, I put up pre-trained tokenizers. Also tokenizers, again, something that there's no one really interested in that, but you need subword segmentation, so why not just having pre-trained models that everyone can reuse? So we have also a repository of thousands of those available soon. And that's the last slide. Maybe I just leave it up here. You can read it yourself, and I can stop with that. There's a lot of thank you that I should improve. Lots of pictures should be here, but there's some sponsors. But let's leave that up here. So I'm looking for contributions always. So get out, get in touch, reach out to me if you're interested in really helping us with that. It's, I think, a good initiative that benefits everyone. And with that, I thank you for your attention.
Okay, thank you lots. I think there was something in your talk for everyone, for the translators, for the users, for the even for the researchers at the end when it became much more complex. So we have time for questions. Who wants to start over there? There's another one. Longer. Press long. Sorry? Okay.
Hello. Hi, Jörg. Thank you very much for the speech. I'm a big fan of your work. So I'm interested in this slide about the benchmarking. Sorry, not benchmarking. The rankings.
The leaderboard.
Yeah, the leaderboard. That's the word I'm looking for. So yeah, when I use the Corpora, specifically Open Subtitles, I found that a lot of the papers that use them, they sort of download the original dataset that you released in 2018, I think, and they pre-process them in their own way. And when you contact them, it turns out everyone kind of pre-processes them in a different way. So I had some conversations at ACL, and kind of me and another researcher came to the conclusion that something like this would be really useful. I'd had no idea this is actually there. So my question is, are is anyone free to submit their own versions of a specific corpus to a leaderboard and then just sort of get evaluated and then we know which one is best, or is that still?
A simple answer is no. So I can tell you, I can tell you how this came about. So I wanted to have this for a long time, and I definitely agree it should be in a way that you contribute your own system. And I think there's initiatives like this is ongoing. What's the Dyna bench? No, what's the different kinds of? But it's really complicated in that sense. You need to set up a submission system and all this thing. This is basically a hack over the weekend, taking the scores that I have in a repository to make it visible and visualize them. So the only way how this really goes about is that I have the data available already. I just made it more nicely available to the outside. So that's it. Definitely, that again would be a nice contribution to extend that, to really have that functionality, submitting, for example, your own models or data sets and all kinds of things that would be possible. Integrating other evaluation scores would be great. But there's, I guess, a longer way to go, and I think we need collaboration to really work on that. As I said, this again was a little hack over the weekend, but the data is there. So what I can do is, for example, I can submit things to the GitHub repository with a score for a model in the same structure as I use for producing them. So that could be a way of contributing in a more low-level way at the moment.
Okay. Thank you very much.
But please have a look at that. So you can also give me feedback about things that those things. For example, if you want to look at the address there, you can just click around. It's actually fun to just look at different test sets and how they behave and what you have.
Okay, other questions? Over there.
Hi, thanks a lot for the talk. I was wondering, so you had this slide where you can select different language pairs and translate from the one to the other. Because Opus is a collection of a lot of data sets, can you actually see where does the translation come from? Which data has been used to train the model? So is there some sort of an explainability on that level?
Yeah, definitely a good question, and I get that question also a lot. So I try to be more systematic and also giving the document the training procedures. One way is, of course, to just publish the training pipelines. That was for me kind of a way of showing how this is done. But it's not very transparent as this doesn't really show exactly, or it's maybe not easy to follow what kind of steps have been done for producing a model. So nowadays I produce at least a bit more metadata that comes together with the model, so you would see what kind of data sets are used. And I focus a lot on a data set that I haven't presented, which is the Tato-Eber translation challenge, if you have heard about that. It's a compilation of Opus data, making it easier to access because it has a train dev test set split, for example, and it comes with a fixed kind of release, so it does not compile things together and then does a lot of things, but instead it's already fixed kind of release data set, so which makes it easier to show that, okay, this is trained on that exact release from that compilation of our Opus data. There's always a lot of room for improvement for documenting things, certainly, but most of those models come with at least some information about how they are trained and the setup. And this hopefully gets better and better over time. The older ones probably have the least kind of information, and the last ones are better on that purpose. Yeah.
Okay, we have another question here.
Big translation companies and translation tools are all building their internal repositories of data, corporate data silos. And sometimes they are quite substantial and also in domain. And they say this is their advantage, which others cannot replicate because only they have the access to the data. But the growth of open source dataset repositories, Hugging Face, Opus, others, is kind of eroding that advantage. What do you think? How long can the corporate silos be relevant, provide a significant advantage to their owners, or will they be completely disrupted by the growth of open source?
No, so I think all these kind of open source is supporting commercial business much more than they are hurting them. So also the data sets, I would say, and all kinds of tools that are developed in open source probably push commercial development worldwide much more than they would hurt them. So in that sense, I don't see it that they would crush their business. So I don't know, that's at least an answer that I would give. Also, those things are not polished in the same way as a product would be polished, for example. So in a sense, a commercial product is still something quite different to kind of research prototypes that we are putting up here. Data sets are still incredibly useful internally. So if you have domain-specific data and you train for those, it's never going to be replicated by open data, for example. So you have internally from your customers some kind of data where you can fine-tune things. This will not be reached without having those data sets. So I also don't see a risk that this is going out of business. I'm not working in the commercial sector, so in that sense, that would be my guess at least. So you're probably referring to my first slide where I said it's a danger to go to kind of risky commercial products, and that's basically also, I think it's more than translation is more than just a product or an application that you can sell. It is getting access to information should be a human right. So you should have that availability to get information available in a language that you speak. So that's why I think this is really important, and I promote always to say that we should not rely completely on commercial products, as this always has the idea of exploitation to some degree. There must be some profit coming out, right? But also from a governmental point of view, you need to have you need to support the entire society, everyone, on an equal level somehow. How can you get that if you have a commercial project only to serve that purpose? I don't know if this is still answering the question that you're asking, but so those 2 points I think would be important for me. So there's different sides. So there's the professional side that probably will stay always because there's so much demand. You will not replace that with the open source development. There will be always so much things that you add on top of that. So this is not going to be out of business. The same answer I have for translators who always ask us, is this kind of machine translation replacing their work? And then I always say that's kind of transport industry. So people were thinking probably once there was the first automobiles, like driving cars were introduced, they would go out of business because everyone would just transport everything themselves. But instead it was just exploding. This is the same with translation. We have so many undone translation jobs which cannot be done because we cannot manage with the human capacity. So there's no way of doing it. But with the tools, you suddenly you can handle those things that people cannot do otherwise. So I see only just an explosion of translation jobs also for professional translators with more tools coming out and available. Sorry, that was a long answer for maybe a different question.
That's nice. I think there's room for 2 more questions.
Thank you. Marko Tadic, University of Zagreb. I want to put you a question about this attention bridge you mentioned. So do you have a way to recognize which language will add or maybe even introduce noise to the quality of translation at the end? Do you have, maybe by some experiments, excluding one out or including one in and so on and so forth? And I ask you that because I have a PhD student who is working now on his PhD. He's training different models to parse Croatian sentences by using multilingual tree banks. And what comes as a clear surprise is that the languages they contribute the most to the highest LAS and so on are actually not even genetically or typologically close languages. And I see your idea, okay, take all Slavic languages together, that might contribute. But there might be maybe languages which are far distant, like Indonesian language, for instance. This one has found out, at least in the parsing task, to be the most important contributor to the dependency parsing system. So maybe the similar thing could happen here.
Could be. I don't have an answer to that because it's really difficult to have very systematic studies. So I think having systematic answers of what kind of languages are hurting, what kind of languages are supporting the most, that's a really difficult and tough question, as there are so many other factors. And I would imagine that the kind of thing that you see might be more related to domains than to actually languages. So maybe that kind of other language that you're seeing as a big supporter might be just a very similar domain, and that's why it's pushing that too much, that much forward. So, but of course it's difficult to say. So what no answer really to that, but there's the possibility of having those data sets around that you could test that, if that would be your hypothesis. I've just recently, in a workshop that we had in Helsinki, there was the work that was presented that certain languages are good giver languages and some other languages are good receiver languages. So some languages seem to be ones that provide a lot of knowledge to many other languages for some reason, and some other languages seem to receive easily information from others, so they can be measured in various ways. I don't know if I really believe that, but it can be, of course, the case that English, for example, because it's so widely spoken, that it is a good giver language.
Just as a clarification, parallel tree banks.
Yeah.
So
okay.
domain is the
okay.
same. So that's
I see. Okay. Yeah. No, I would not. Well, that's a surprising thing that if you see that kind of factor. But maybe there's kind of syntactic overlap in structure so much in those distant languages that for that specific task it might help it, in others it doesn't. I don't know.
Okay, a very last question then.
Hello, I was thinking, what about multimodal resources? Because today we have a lot of parallel corpora with speech or image. Is there space in Opus for such resources?
Yes, definitely. I would like to have them, but so far we don't have any of those. Would be a nice extension. So we have not really worked on that to include those. Speech would be a natural next thing, I guess, to include. I've not really been working on speech myself that much, so maybe that was also a bit of a not really on my radar in that sense. But definitely would be nice. Space. In terms of course, space also becomes then maybe an issue at some point if you have multimodal data. Of course, the space explodes, but so far you don't have those huge data sets anyway, so I would not see a problem there either. And as the community is probably very much interested, I can also convince, for example, our IT infrastructure that this is an important thing to provide. So definitely, if anyone has those data sets, please let me know. I can definitely take them. Tatoeba itself actually has audio for some sentences, so that I should definitely include. Yeah. Images, I haven't really thought about that yet, but maybe that could be interesting as well.
Okay, I think it's really time to conclude. Let's thank Jörg again, and if you want to